I'm Associate Professor Alan Wiseman at the University of Wisconsin-Milwaukee. We're standing in the LIGO computing facility here at the university. This is a very large computing facility for analyzing gravitational wave data from the LIGO detector. Gravitational waves are produced by very violent astrophysical events in the cosmos. Things like two black holes colliding or stars in orbit around each other very rapidly. For example, the Earth orbits the Sun once every year, but the types of events that I'm talking about are where we have two objects, say roughly the mass of the Sun, not orbiting once a year, but orbiting 100 times a second. These produce ripples in the fabric of space and time, and those ripples travel through the cosmos, and that is what's detected in our gravitational wave detector. These sites take data at a tremendous rate, record gravitational wave data at a tremendous rate, some 10 megabits per second. This is a rate which would fill the disk on your home computer in a matter of minutes, or at least if you have a large disk, maybe an hour or so. So this data is transported over the internet to various sites around the world, including this one. The data comes in over some fiber optic channels. It then lands on a number of disk drives over here. Each one of these machines holds 16 very large disks, and you can see there's about 24 of them. So this stores a very large volume of data. The data can come from our network servers through our internal switch here, and then is farmed out to these nodes. They start their jobs and run on 100 or maybe even all of our nodes at one time. Down this aisle, you actually get a good perspective of the scale of the operation. There are 300 computers along this row, there's 300 computers along this row, and there's actually another 180 computers along this last row right here. As you know from operating your home computer, that they all put out heat. Each one puts out about 200 watts, and we have 780 of them. So we have about 160 kilowatts of heat in the room that has to be removed. That's basically equivalent to lighting up 30 pretty good sized ovens in the room. In order to remove the heat, we have 4 air conditioning units in the room. These are what we call 25-ton units, which gives us 100 tons of cooling in the room. As you can imagine, 780 computers use quite a bit of electric power, so we actually have a very significant power supply coming into the room. We bring in 480 volts three-phase at about 800 amps, comes into the building, from the basement into here, and this is an uninterruptible power supply, which means we actually do have battery power to run the computers for a few minutes in case power fails. And these are powered by about 9,000 pounds of effectively car batteries here. In order to get all this equipment into the room, it was too big to bring it up the elevators or up the stairways, and so we determined that the easiest way to do it was actually to knock a hole in the wall, which we did behind that air conditioning unit, and actually crane everything into the room and then brick the hole back shut. That was the simplest way to do it. Most of the maintenance work on the facility is actually done by UW-M undergraduates who we just employ as student hourly help. And so they actually get to participate in some real cutting-edge research by maintaining this computer cluster. The one site I would call your attention to is the Einstein at Home website. This is a website where you can actually participate in gravitational wave data analysis and actually access some of the equipment that's in this room.